Now, once we can write down the chemical formula, next we want to name it because every chemical has to have one and only one name so we can identify what the chemical is either by the chemical formula or the chemical name. These last two examples both involve a metal with a nonmetal when we form an ionic compound. And the rule when you name it, the metal gets written first, just like notice in both examples, we always wrote the cation first and the anion second. That's the proper way to write an ionic formula. It would be wrong to write SMG. It has to be the magnesium first and the sulfur second. So the metal is named first, and the name of the metal stays exactly the same as the name on the periodic table. And then when you have a nonmetal from the periodic table, we're going to change the ending to an IDE, an IDE ending. So for BAF2, the barium is still barium. And then we have a space, and then we name the fluorine, but we're going to change fluorine to fluoride. So the proper name of BAF2 is barium fluoride. The same way, we could name MgS. Magnesium stays magnesium. Then we have a space, and sulfur changes to sulfide. Now, naming ionic compounds gets a little more complicated when you remember from chapter 4 that some metals, especially the transition metals, can have multiple charges. Those were the elements that we could not predict which charge we would get just by looking at the periodic table. So one example was the main group element lead. Lead is found in group 14, and lead would be predicted to have a charge of positive 4 based on the fact that it is in group 14. But remember, lead also exists with a positive 2 charge, which means we have two possibilities for the cation, and if we were to make an ionic compound of lead with chlorine, we would get two different answers. Chlorine is a nonmetal in group 17. Take the last digit 7, subtract the magic number 8, and you get a negative 1. So if we take the positive 4 version of lead and we do the crisscross with the Cl minus, we'll end up with 1 lead and 4 chlorine atoms. However, if we use the positive 2 version and do the crisscross, we'll end up with 1 lead and 2 chlorines. The red and the blue are different chemicals, so they must have a different name. We have to be able to tell from the name whether we're talking about PbCl4 or PbCl2. So the extra thing you have to put in the name is the Roman numeral, which is the charge of the cation. When the cation has more than one possibility, you must give that in the name. So PbCl4, it would be incorrect to call this lead chloride because you wouldn't be able to tell the difference between the red lead chloride and the blue lead chloride. So the red one is lead, then parentheses and Roman numeral 4 to tell you you're dealing with the positive 4 version of lead, then a space, and then the anion chlorine changes to chloride. Where the blue chemical is also lead, but the cation charge was a positive 2, so this would be lead 2 chloride. And remember, if you're entering an answer in Roman numerals on your computer, you want to use the uppercase I, not the L,